Good day, Waterford Estate residents. Today we're going to be discussing the Waterford Estate River Servitude Rehabilitation Project. The project team consists of three people at the moment. Bruce Webb, who's a retired construction engineer, myself, Jason Hallows, who's a hydrologist, and Miles Parr, who's been working on this for a while. Miles has managed to get the general authorizations and licenses required for us to do construction and rehabilitation in the river servitude. If we have a look at the problem statement, the erosivity of the stream has increased due to developments upstream. Essentially what's happened is this has eroded away the channel, and finally we've hit the rocky base and it's started to erode laterally. This is now starting to undermine the banks. This is leading to problems of slope stability. Currently the riparian vegetation is maintaining the banks, but this is not a sustainable scenario. If we have a look at this, here we have a steep embankment. You can see the stabilizing vegetation, mainly trees. And then we have a lateral erosion, which is undermining the banks. And finally, we have a rocky base layer, which I mentioned earlier. We're not going to be eroding below that. We're very close to the fence in some areas. This is looking downstream. You can see that the path hardly exists any longer in some of the areas, and it's very close to the fence. Similarly, looking upstream. Slopes are maintained at a gradient of roughly 2 to 1. And if you go beyond that and are steeper than that, generally they fail. So we anticipate in most of the cases along the embankment that we'll have some slope failure at some stage unless we stabilize them. If we have a look at the current project status, licenses have been received. We've done some initial information collection. We've done initial designs of the gabions, but we're going to look at different options related to that. We've done initial options analysis and decided what we're going to do. We've done a rainfall extreme event analysis, a runoff extreme event analysis, and we're looking at scenarios simulated and completed. The various options that we have a look at for rehabilitation, the first is putting a gabion structure across the stream. What this does is essentially dams it up and raises the base level of the river. Slowly over time, this should sediment up, and then eventually you get a wetland sort of forming above that. There are problems with gabions, which I will go into in a little bit later. So here are the elements of concern. We have no optimal placement of the gabion structures in the initial designs. Downstream considerations haven't been taken into account, so the erosivity and the velocity of water increases as you go downstream. The gabions could fail, and this can cause major issues in many cases. Debris buildup can collapse this, and if you get a debris failure, it can be much worse than actually not having put the structure there in the first place. Then finally, the sidewalls can be eroded away, and this can cause major concerns. And we do have eccentric velocities down the river stream due to a meander at the top of the river. The second option is embankment protection. Essentially what you do is you terrace the banks with various structures and put some stabilizing vegetation onto that. The preference of this particular solution is that there's no obstructions in the actual river itself that can be sort of forced away and changing the natural flow patterns. And generally these don't erode so easily because they're parallel to the stream flow. Channel straightening is another option. Essentially, you take a meandering channel and you straighten it out. The water then is able to rush down relatively unimpeded. The problem is that quite often these channels get slightly clogged and you get erosion happening anyway. Added to this, it's quite an expensive construction project to get the equipment in to do this. So we did some scenario modeling with some LiDAR information. LiDAR is a very accurate surveying method which uses laser detection on the base of an aeroplane. We wanted to test various scenarios. So what was the impact of the meandering with the gabions? What is the best design structure with the gabions? Should we construct just several smaller gabions or two large ones, something like that? Which areas are currently a major risk? And what are the consequences of failure of the structure? So if we had a look at the scenarios, the first thing that we did is some hydrology. The catchment area is around about 5.9 kilometers squared. We used a method called the SCS method to determine the return period. We're getting a peak flow of 57 meters cubed per second at the time of concentration of roughly 37 minutes after the heavy rainfall begins. That's what the hydrograph looked like. It's a simplified hydrograph. They're usually not that triangular, but it's for our purposes, it's fine. Here we have an aerial photograph of the area that we're looking at. This is near the estate, and that is the LiDAR image, which you can see is quite accurate in capturing the stream very nicely. You can see the meander over here at the top. That's where that old weir structure was. Here we have no intervention, sort of current state of water flowing down. The redder it is, the higher the velocity. You can see that there is some high velocities in this area striking this gabion structure, but you'll also see that as it meanders down a bit, there's certain erosions that are happening in various areas. This is further down. There's a major tree stump in the way at the one area which diverts the water around two different areas and has eroded away this area over here already, which has been stabilized, and that shouldn't pose too much of a problem. In terms of the gabion design, we decided the gabion design that they currently have is very standard, and it's can fail very easily. So we chose a triangular pattern like this, and with a stepped gabion, which is generally to handle different flow velocities. What you see over here is the situation where we've put the gabion in an upstream position. It slows the water down with the damming effect, which you would anticipate, but what you can see is as it's going over the gabion, you get a lot more energy with that water, which can cause some serious erosion in some of these other areas downstream. Similarly, we placed another gabion further down below the tree stump area. What you can see is that slows the water down and stops the erosion around the tree stump. There is some high velocity water sort of coming into that area. We then also did a scenario where we took out the tree stump and put a gabion just upstream. What you see is the gabion channels the flow and concentrates it, so it goes through that area. We're not getting so much of a problem in these other areas, although we are getting some eddying around here. The major problem over here, though, is that the gabion starts to cause side erosion, which can cause embankment failure, which is something that we'd like to avoid. Here's a 100-year flood simulation of the area. So we've got the flood coming down, got some water, and then it's filling up, and you can see it fills up quite substantially and starts to slightly overtop the banks. There's no threat from the 100-year flood line at the moment. Most of the properties are well designed and out of the harm's way. If we have a look at an actual simulation of the area zoomed in, this is the top meander. What you can see is you get these eccentric flow velocities which cause eddies, and those eddies can then erode out various places, particularly let's say over here, and that's something that we want to avoid. So that is a little bit of a worry from our perspective. Finally, if we have a look at the project plan, we've actually completed quite a lot of the elements right down to the modeling scenarios. We're now looking at engineering redesign for various structures. We're going to embark on stakeholder interaction, and this particular presentation is the beginning of that. We're looking at contracting and procurement, and then construction are the final phases associated with that. In terms of recommendations, initially what we wanted to do was have a look at multifaceted approach to the project rehabilitation. So we're going to redesign the gabions. We're going to have a look at various channeling to reduce the meandering, look at protection measures to stabilize the embankments, and then we're looking at straightening the river courses in some places if possible. On review of the simulations, it's been decided that these options are actually not great. So it looks like the protection measures that we're going to take is stabilizing the embankments and making sure they don't fail. To this end, the way forward, we're going to stabilize embankments. The first thing is we need to remove some of the larger trees where the treetop biomass can cause failure by pulling out various chunks of earth from the embankments if they fall over. And that's something we want to avoid. So various trees have been selected and identified. People will be contracted on the boundary who are influenced by the tree removal. The trees will be felled. The area will be revegetated with indigenous trees after that. Then we're going to set up bank reinforcements, particularly on the lower sections of those banks to stop the erosion from occurring next to the river, and then they'll either be gabions or other structures. It will depend on the engineering design. These will be running parallel to the river, and they'll probably be bolted into the rock areas where necessary. Then we're going to establish terraces with other material, particularly the leaves, etc., are going to be there. Then we're going to establish terraces above the low embankment protection. And we're going to do this while we're able to gain access to larger machinery. And then we'll monitor and repair where necessary. We think this is the cheapest option and the best way to go forwards. Thank you very much.